we get started, let's take a quick look at the evolution of the cloud landscape. I know that this has been the buzzword, so to speak, since the last several years now. If you look here, you'll see that as we started this migration to the cloud, it started out in a bunch of different flavors. So there were combinations of hybrid cloud, which is part on-premise and then part of your workloads residing in the cloud. Then there were also public cloud. There was private cloud, of course, due to security and other reasons. There were a lot of enterprise companies that preferred starting out their cloud journey with a private cloud instead of a public cloud. But what we can see here is that over the last 3 years, of all of these different combinations that we just talked about, the public cloud is the only one that's been growing. So we've been seeing an increasing trend of enterprises wanting to move more and more of their workloads to the cloud. We'll be talking about some of the benefits, of course, but in general, at a high level, this is, of course, because of the flexibility that a public cloud brings to the fore. So you don't really have to worry about the management aspect of it. You don't have to worry about things like scaling up, scaling down, failover, disaster recovery, things like that. And as we evolve, we expect to see more enterprises wanting to leverage these capabilities that are all provided by public clouds. If we take another step in this direction, again, we're looking at the industry trends here. You'll see that the top couple of reasons or the top couple of projects that enterprises are really investing in are optimizing their existing cloud use, right? So this is, companies that have already invested in the public cloud to some extent, but they just want to optimize more. Again, this may be for cost savings or other motivations as well. And then there are companies that are starting to move more and more of their workloads to the cloud. Databases, of course, are very central to cloud migrations, but as you know, they're also really tough. And this is due to a number of different reasons, right? So we're going to take apart maybe a couple of the top reasons. The first one is, of course, there's a lot of proprietary technology and functionality that's built into a lot of the legacy database technologies, right? So if we talk about Oracle, I'm just using that as a frame of reference here, that may be things like stored procedure, custom functions, Oracle RAC, so on and so forth. So this makes it really hard for you to migrate to an equivalent cloud-native technology. The second one is, of course, your historical on-prem databases are all pretty monolithic. So these are humongous servers which don't really fit into the cloud way of doing things, right? So oftentimes, again, if you take this huge monolithic server, you have to split it up into multiple servers in the cloud. And the third thing, which a lot of companies actually maybe underestimate, is the reliance of applications on databases, right? So if you think about a company that's been around for, let's say 10, 15 years, as your business grows, you have like hundreds or thousands of apps, both internal and external facing applications that are all relying on the database. Right? So as you're thinking about migration, it's really important for you to consider the risks that are associated as you're migrating these to different cloud-native technologies, and obviously trying to minimize your exposure as you do this. So because of all of these complexities that we talked about, we see two general types of database migrations, right? So there's homogeneous migration, which is also commonly known as lift and shift, where you're retaining the same database engine, but you're just moving over from on-premise to the cloud. While this does bring some benefits, like for example, you already have like a trained up staff that understands the technology, that's really familiar with it, and so there's not as much of a learning curve associated with it as you're migrating the stack over to the cloud. So that by itself extends into faster migration time as well. And like I said, in this case, because the database engine is still the same, you have fewer application rewrites, which of course means that in some cases you might have lower risk. Now, that being said, there are also some challenges that we briefly talked about in the previous slide, which is server sizing and configuration. Like I said, if you're talking about huge monolithic servers, moving this to an equivalent way in the cloud is going to be really tough. So you have to think about how you can split up this huge server into multiple different servers. The other type of migration is called heterogeneous migration. People commonly also use this in the same vein as modernization or digital transformation. which is essentially saying that, okay, I want to port over my database engine. I've already invested a lot in these licenses, and the cost of maintaining those licenses is actually going up with every passing year. And as my business grows, I'm actually building a lot more applications on top of that. So what that means is that you're saying that, okay, I'm going to make a business decision to invest more in the cloud, and I'm going to do what I need to do to actually make it fit into the cloud way of doing things. Now, some of the benefits for this, we commonly see, cost savings or, lowering your TCO is one huge thing that we see. The second thing is also reducing your reliance on a particular technology. As we've seen the evolution of public cloud, there are more and more open source based technologies. So we're going to talk about Postgres today and a little bit about MySQL as well. And we see this across the database spectrum, not just in the relational world, but a lot in the non-relational world as well. So by moving to these technologies, you're actually lowering your reliance on a particular vendor as well as the proprietary technology that comes from that particular vendor. And then, of course, because you're in the cloud, it makes it a lot easy for you to scale up and down as needed, so that you don't have to have like reserved capacity at all times. So if you're a retailer who's thinking about peak season times like Black Friday sales or Christmas holidays or something like that, you don't really need to hold on to that capacity for the rest of the year. You can scale up and down as needed, and you don't really have to worry about that. The other thing is, of course, failover and disaster recovery. Instead of investing in your own data center and maintaining them all around the year, you can actually offload that to the cloud provider, right? And as we move into the cloud way of architecting our applications, of course, more and more companies want to just take care of the innovation piece, right? The things that truly help you derive business insight and value, instead of things like, how do I manage my infrastructure? How do I manage my database? How do I configure this? They don't really want to get into the business of doing that, and they would rather have the public cloud provider take care of that. Of course, some challenges with this, it's going to be a more complex, probably longer migration effort. And when you're moving from one database technology to another one, you also have to be mindful of things like schema conversion. Another thing that we talked about was, especially if you're talking about production grade applications, you have to make sure that there's no data loss, right? So that's where your real-time change data capture comes into play, making sure that you're able to migrate your data in real time instead of doing it in batches. Right? So these are the challenges that we typically see. So now I'll hand it over to David to take us through the key steps that are involved in any database migration, and then we'll get into the details specifically from migrating your databases from Oracle to Postgres.
Thank you, Kavitha.
Yeah.
So every database migration project is complicated, specifically when it comes to heterogeneous database migrations, because as Kavitha mentioned, there are challenges which we can overcome, but there are challenges. And what you see here is kind of like taking a database migration project and breaking it down to, I would say, the 6 primary steps. And we're going to go through each one of them, talk about some of the, I would say, areas that you should be made aware of, some of the tips and recommendations we can share from our experience. As I said, we have done countless heterogeneous database migrations, both on-prem, and of course, obviously on-prem to the cloud. So we would love to share this experience with you. So let's go over the steps, starting with assessment and source discovery. So this is extremely important because it's the first step in your database migration journey. You need to start by understanding what you currently have in your existing environment. Specifically, this talk is about Oracle to Postgres migrations, to Cloud SQL Postgres migration, but this is also applicable when you change database engines from other source and target technologies. Understanding the source environment, what you currently have running right now, the layout and structure of your Oracle databases before you even start the migration might seem like trivial, but it's super important. And that's because a lot of the features which you may be using right now in your Oracle database, your high availability configuration, you may be using Oracle RAC or DataGuard. You might be using some proprietary features. So you need to be made aware of these before you start your migration, so you can plan to mitigate any, I would say, functionality that might be missing in Postgres that you're currently using in Oracle by leveraging other Google Cloud technologies, and we'll see some examples of that, or sometimes even by writing custom application code. So that's the first thing that you need to do when it comes to database assessment and migration. You also need to be able to determine when you do your migrations to Google Cloud, and specifically when you choose cloud-native database technologies such as Postgres and or MySQL, you also need to make a decision which database engine is better for you. That's because a lot of the functionality that you may have, sorry, I just skipped a slide. A lot of the functionality that you may have in your source Oracle database might only be available in MySQL or Postgres. And we're going to talk about that as well as show you some tools and products and tips that can help you make the right decision. So assessment and source discovery is very important. You'll need to review your database configuration, your schema, your database sizing. As Kavitha said, very large monolithic databases might need special attention when it comes to migrations. You need to make sure and see if you're using any proprietary features. You need to take a look at your database workload because because as you know, applications which were developed to run on an Oracle database might use some Oracle-specific SQL syntax. Or even when it comes to if all of your applications support other database engines such as Postgres, your workload might behave differently. So performance tuning is also an aspect, and we're going to talk all about that. But assessment and source discovery is extremely, extremely important. Also, as shown on the slide, you have to understand what applications connect to your database, because when you move a database to the cloud, you're saying, you know what, I'm going to move my Oracle database to Cloud SQL Postgres, for example. You need to make sure you understand which applications connect to the database. Can these applications be ported to Postgres? Maybe they are compatible with Postgres. If you have legacy applications, it's going to be a much more challenging migration process than if your applications are relatively modern. So the assessment and source discovery is very, very, very important. And there are two ways to actually do that. So the old-fashioned way of kind of figuring out what you have running right now, you might have a CMDB database somewhere, but drilling down to the actual databases, understanding what are the features that you have, the configuration, what high availability infrastructure you have in place. You can either do it by running scripts, SQL scripts, and you have a bunch of code that you can run on the database to detect what are the features you're using. You can query the Oracle Data Dictionary for understanding what schema object you use. You can query the Oracle AWR repository to understand what's the workload running in the database. But we also want to talk about the product that we have developed. As I said, we've been doing these database migrations for a long period of time, which kind of takes all of our experience and puts it in a product that can automate the assessment and discovery for you, and that's Migrating, which we're going to show you a demo. Migrating for Google Cloud, which we are officially launching today, is a custom-made product built for Google Cloud, which can scan your existing Oracle environment and help you create your migration plan, show you what databases you have running, their configuration, the proprietary features, show you the migration complexity for both Postgres and MySQL running in GCP, and we'll see a live demo, which I think is very cool. But we think at least, that's the reason we created Migrating. It's a much faster way and a better way to start off your migration journey instead of having to do everything manually. And as I mentioned previously, it's also extremely important when you start your migration before you actually, and we'll talk about in the next steps in the migration process, but before you start converting your schema and moving your data and kind of decide, actually implementing the migration itself, you have to choose between, if you're going to leverage cloud-native technologies, if you're going to leverage Google Cloud SQL, if you're going to leverage open source database engine, you have to choose between Postgres and MySQL, which again, depending on the specific proprietary Oracle features you're using, the types of schema objects that you'll have, Postgres or MySQL might be a better fit. And again, our product Migrating can help you make that decision. And as you'll see in a moment, but again, this is an important step you have to take into account. In addition to the structure of your source database and the compatibility of certain schema objects, you also have to kind of take into account if your IT staff is more familiar with Postgres or MySQL. These are the non-technical requirements, but they're also very important, and also your applications. So if you're moving your database and its application to GCP, you're going to leverage Cloud SQL Postgres, for example, but the applications that run on this database right now happen to be, I don't know, support both Oracle and MySQL, so maybe MySQL will be the better option. So also, you have to take that into account as you start planning your migration journey. So there are, on the technical aspects of choosing between Postgres and MySQL, and again, this talk is mostly focused on Postgres, but it's still something that's important kind of like to mention. So there, as I said, there are schema objects that you might be using right now in Oracle, or features that you might be using right now in your Oracle database that are supported in either MySQL and Postgres. You see some examples here, such as sequences, which are only supported in Postgres, user-defined types, which are supported in Postgres, but virtual columns, on the other hand, have better support in MySQL. Partitions, for example, Postgres 10 is the first version of Postgres that added declarative partitioning support. Postgres 11 expands on that, but MySQL always had a partitioning mechanism that's more closely resembles what you originally had in Oracle. So there are differences, okay? And it's very important to kind of keep that in mind. And this is just like a few of them. There are a bunch more. And again, we're going to show you in the Migvisor demo how it can help you, how our product can help you identify those features and kind of tell you, hey, so this database might be better suited to run on Cloud SQL Postgres, while that database might be more compatible with Cloud SQL MySQL. So again, just keep that in mind as you kind of start your migration journey. So Migvisor for Google Cloud, which again we are launching today, is meant to automate your source target discovery and assessment phase. It detects your database configuration, your schema configuration, the schema object that you're using. It gives you like an overview of, hey, this is your existing Oracle fleet. These are the proprietary features that you're using. These are the schema objects that you're using. And then assigns a migration compatibility score, migration complexity score to both Cloud SQL MySQL and Cloud SQL Postgres. As well as, by the way, if you just plan to run Postgres on a compute engine. So there are also differences there, which we'll talk about in a moment. So it meant to automate this process and kind of give you in a very visual way a lot of insights and metrics and dashboards that are relevant for your migration process before you even start migrating a single database, which is, again, super important. You don't want to start a migration and then, as you go through it, kind of realize, oh, wow, we forgot that this application connects to the database once a quarter to run a report, and it's not compatible with Postgres, so that like puts a stick in our wheels. Or, oh, wow, we have so many synonyms. We have like over 100,000 synonyms in our database, which we have seen databases that have such excessive number of synonyms, and that's not supported in Postgres. So what do we do? Should we create like views as workaround? So all of that is kind of like presented in Migvisor. Our product has two components. So it has the web console. It's a SaaS product. So you have the web console where you see all of our migration insights, all of the details about your environment so you can explore and see how your migration is going to look like. And also, we have a very small standalone component known as the Migvisor metadata collector, which is a standalone Java utility you need to download and run it on a server in your existing environment. It can even be your laptop. You do not need to install it on the database itself. Our metadata collector, what it basically does is opens a JDBC connection to your existing fleet of Oracle databases. It can connect to thousands of databases in one go, so it supports like analyzing your databases in parallel. Runs a bunch of queries the Oracle Data Dictionary, queries the Oracle metadata tables, the Oracle AWR repository, gathers all of the information that's needed for the migration analysis, and then creates a local zip file encrypted, which you upload to our console, and then boom, you see all of the migration insights. So that's kind of like the architecture for our product, and we created it so it would be extremely easy and simple to use. Again, you don't need to install anything on your source databases. You only need one metadata collector, no matter how many Oracle databases you want to analyze. And we see, our users, when they want to analyze your Oracle environment for Cloud SQL migrations, for GCP migrations, we see them being able to, from start to end, from actually being able to access the migration insights, it's a matter of minutes. Okay, and traditionally, if you were to do this using scripts and like running and creating like spreadsheets and Word documents, kind of mapping your existing environment and kind of trying to figure out which application connects to what database and what are the complexities, it would obviously take much longer than that. Sometimes, it's days minimum, sometimes even weeks for a large fleet of Oracle databases. So before the demo, just a few other slides I want to talk to you about. So essentially, all of our migration insights, all of our metrics, everything that we kind of show and surface in Migvisor, it all boils down to a migration score. So we basically give each database in your environment a score from 0 to 100, depending on how complex it is. So I just want to show you a couple of examples of, two examples of how would a low complexity database for migration would look like versus a high complexity database. And you'll see more in the live demo. So for example, we have an easy migration database, an easy database to migrate. So this is an Oracle database that has, of course, some proprietary features. It has some Oracle-specific schema objects. Makes sense. I mean, it would be rare to see a production Oracle database that just has a bunch of tables and indexes, right? So the features that we detected in this database, such as job scheduler, inter-region data guard, certain tables and data types, some functions, stored procedures, indexes, all of those aspects have compatibility with, say, Postgres as a target platform. So the migration score would be low, and would even, when we kind of show you our migration insights, we'll even give you tips, what we call migration tips, on, hey, you're using Oracle Job Scheduler to maybe run jobs in your database like on a recurring basis. There are alternatives you can use. So we're going to show you, maybe use Apache Airflow, for example. So we're going to show you that in our product as well. So it's very cool, and again, this is just an example of a low complexity database. We also look, by the way, at the stored procedure code and kind of trying to figure out if you have any usage of proprietary Oracle DBMS packages, UTL packages, certain SQL syntax that might be only compatible with Oracle, such as a connect by expression, which might not be supported fully. So again, very easy database to migrate. On the other hand, there will also be databases which would be more difficult. In a big Oracle environment, you'll see a mix of low complexity and high complexity databases. That is expected, but you want to be made aware of that beforehand. And maybe that's how you can prioritize which databases you're going to move to cloud native open source technologies, and which database you might want to do as a lift and shift project. So here is a more complex database. So it's a RAC database, which would require re-architecting your database for deployment because you're using an active cluster. It has a lot of database hints. So you can have multiple stored procedures or SQL queries where you're manually influencing the behavior of the Oracle optimizer. So that would probably indicate that performance tuning, when you move to Postgres with its query planner, which would probably run those SQLs differently, would require a big effort. So that's another thing you need to keep in mind. It has synonyms, which are not supporting Postgres, but we will tell you, hey, maybe move these to views, migrate them to views. It has user directories, so you're probably accessing files from the operating system from within the database. So that would require, again, maybe moving to Google Cloud Storage. Database links, same. So what you're going to do, you currently have this Oracle database accessing other Oracle databases, so you need to keep that in mind. Maybe you cannot move this database in vacuum, and you need to maybe move a bunch of databases together. And again, usage of DBMS and UTL proprietary Oracle APIs inside your stored procedures, multiple partition tables. Some of them might be like hash partitioning, which is not supported, only supported in Postgres 11, if I remember correctly. Fast refresh materials views, complex queries. So again, just an example of how would a high complexity database for migration would look like. And the benefit is that you'll be able to determine, if you have multiple Oracle databases, which are the ones that are going to be the quick wins, the low-hanging fruits, the one you can get maybe move to migrating to Cloud SQL, Postgres, and MySQL relatively easily. So let's maybe do a quick demo of our product just to show you Migvisor in live action. So if you can switch to my computer, please, that would be fantastic. There we go. So this is our login screen. Again, it's a SaaS product. When you log in, the first thing we show you is a high-level overview of your core environment, such as how many databases have you actually analyzed using Migvisor. This is just like a very small demo environment. The server sizings, number of CPU cores. We also show you the comparative migration complexity. Here you can see for running Postgres on compute versus Cloud SQL, Postgres versus Cloud SQL, MySQL. We also show you, again, depending on the target that you choose, a very high-level overview of the specific complexity per database, but we do surface a lot more details. This is just like a high-level overview of your existing environment, so you'll know what you're dealing with before you dig deeper. And then I think the coolest feature is that you can actually simulate your migration before you actually perform it. So say we're interested in moving Oracle to Cloud SQL, Postgres. That's what we're interested in. So we choose the source and target combination. We click on Analyze. Then we can choose, sum of all of our database server. Click on Analyze. And the first screen we see, it's a very high-level screen that even if you're not a database administrator and you have no database background, what we do is rank your databases based on migration complexity from lowest to highest. So without even digging deeper, which we'll see in a second, I know that I have databases where the migration complexity is going to be very low. So maybe here is my POC, here is my prototype database for heterogeneous migration, versus other databases where it's going to be more complicated. So it doesn't mean that we cannot migrate them. It just means it's probably going to be a more challenging process. It's often worthwhile, but just surfacing those details beforehand. Clicking on each one of those databases, that's where you start to see like the verbose information. So each one of those bars is of course clickable, and we can also kind of show all of the databases in one screen. And then this is where we present all of the individual features that we have detected in each one of the source databases that can make your migration easy or more difficult. We also show you some server-related information for sizing. Here are all the features that we have detected. So this is, for example, a RAC database. It has 103 database scenes, and we actually show you like the schema name and the actual procedure name or where we found the database scenes. It has over 1,000 synonyms and so on. As you see, our list of the features that we detect, which is over 100 different features, in Oracle is quite extensive. And we also flag those features based on the migration impact, high, medium, and low. So it also takes into account the number of usages for a feature. So it's not just, hey, we found usage of Oracle's DBMS random package. It's because we found only one usage of it. So even if you have to manually code an equivalent for DBMS random or use like the Postgres equivalent, it's not going to be that difficult. But if this was like, 1,000 occurrences, then it might be a little bit more difficult. And we also provide those migration tooltips. So when you click on this little eye icon next to each one of the features that we detect, we show you a small, short, and to-the-point tooltip of saying, why was this feature flagged? Is it going to be a problem? Yes or no? How can you work around anything that's not supported? And we also provide links to the actual Cloud SQL documentation. So for example, for synonyms, you'll see clicking on it will just say, hey, so synonyms were detected, however, they're not supported. You can use views or maybe the set search path in your queries as a workaround. And again, we try to provide this information for each one of the features that we detect, provide multiple alternatives if possible, just so you'll know that before you actually start your migration. We also provide the ability to do schema-based analysis, so you can exclude certain schemas from your migration analysis. Let's say you want to peel off individual schemas and move them to GCP. We also kind of help you perform target sizing, so we show you the memory, I/O, and CPU requirement for each schema, which can be, again, very useful, because we see a use case where people take these monolithic Oracle databases and break them up, split them up to smaller Cloud SQL instances. We also show you a list of all of the applications that connect to the database, just so you won't forget any application, when you do the migration. If there is this reporting tool that connects, once in a quarter, but generates a report for the CEO, super critical. But that's, it's a legacy application written in Oracle Hyperion BI, something that's not compatible with, more modern cloud-native technologies. You want to be made aware of that. We also show you, we do a workload analysis on the database, showing you on a per schema level and per instance level, is this an OLTP database, an analytics database, the ratio between OLTP and analytics queries per schema, maybe BigQuery would be a better alternative for certain schemas where the workload is predominantly analytics. So we show you this information, we kind of surface that. We also show you database links, schema dependencies. So again, all of this information is meant for you to understand what you're dealing with before you actually start your migration process. We also flag OCI applications that connect to the database so that you'll know if your application mix is modern or legacy. And again, we encourage you to use, so Migvisor for GCP is going to be made available in the marketplace soon. Right now, if you want to use it, you can reach out to Kavitha. And we do encourage you to use Migvisor for Google Cloud as the first step in your migration process. We think it's very valuable and can save you a lot of time. And kind of we try to just take our experience and kind of from database migrations and kind of turn that into a product. So that's Migvisor. If you can please maybe switch back to the deck. There we go. So that's database assessment for you. Again, it's the first step, and we encourage you to put effort into it. so that you will basically know what you're dealing with before you actually start the migration process itself. The second step is, success criteria. So might seem like trivial, but it's actually very, very important. There are multiple steps when you actually start migrating your database, converting your database. There are multiple steps you have to take into account. You have to make sure that all of your schema objects were converted successfully. You need to plan for functionality testing. So you moved your database, you converted your schema. We'll talk about schema conversion in a moment. You want to run a representative test of your applications, of your current application workload on the target database to see that nothing breaks, right? You want to make sure you plan for data validation. So as you move your data from your on-prem environment to Cloud SQL, you want to make sure that all of the data has been replicated successfully. And we'll talk about those steps in a moment. This is just like understanding what you need to do for you to be successful and planning for that. You need to do performance testing. Even if your applications are fully compatible with Postgres, right? Just switching the JDBC driver and everything would run fine. You're only using ANSI SQL syntax, so no proprietary Oracle join syntax or all-up functions or none of that stuff. Even with all of that, the queries will behave differently. Different databases, different query optimizer, the execution plans will change, and queries that might have behaved in a certain way, maybe using indexes, might suddenly switch to full table scans, right? So you have to make sure you plan for performance testing as well. It's super important. You have to also plan for integration testing. So as I mentioned, a database is not in vacuum, doesn't exist in vacuum, because in addition to the application, you might have dependencies on other databases or other technologies in your organization using Oracle Database Links or application tier integration APIs that need to kind of query multiple databases at the same time. So you have to plan to make those tests as well. And again, the same tests that you have to do on the database level, you also have to do that for the application. So unit testing, performance testing, integration testing, again, and plan for all of that. That's your success criteria for migration right here. The next step would be to actually, start, getting your fingers dirty and actually starting doing the migration itself. That normally starts from the environment setup. So you have to kind of create the target environment in GCP. That means that you have to first convert your schema, and that's a hot potato, because we can detect, using Migvisor, for example, a lot of proprietary features you're using. We can surface those details. We can give you tips on what you have to do, but you'll still need to actually perform the migration. So you have to leverage different APIs, convert your stored procedures, convert your materialized views, for example, your partition tables, all of that stuff. Now, there are tools such as Aura 2PG, which is an open source tool that can help you automate a lot of the schema conversion process, right? Depending on the complexity of the source database, the success rate from our experience go anywhere from like 30-40% automatic conversion to sometimes even 60 or 70%. But it's never 100%. So for the schema conversion piece, leverage automatic tools such as Aura2PG, but you'll also need to put some elbow grease into it. You have to put some manual, honest DBA work to kind of convert some of the more trickier schema objects, some of the more trickier stored procedures. So that's schema conversion. Okay, it's part of your environment setup. Before you move the data, before you test your application, you need to make sure you have a fully converted source schema. The second aspect is, well, you'll have to deploy your Cloud SQL target. So you have to understand what's the sizing that you want your Cloud SQL target to be comprised of. So how many CPU cores, how much memory, right? What's the IOPS requirements? If you're breaking one Oracle database to multiple Cloud SQL instances, you also have to keep that in mind. So you have to size intelligently. That's what we always say. And you can reference, I would say, that's as a tip, reference the workload you have on your Oracle database and not the physical hardware configuration as your baseline. That's because cloud economics for scaling are different from on-premise economics. And we see a lot of times we have these big monolithic Oracle databases running on, which have been over-deployed. So an organization bought like a very high-end, super capable, like server with like hundreds of CPU cores, terabytes of memory, just in case, because they know that they might need to scale up. They know that they might need like room to grow in the future, so they have over-provisioned, okay? Not all of the databases are like that, but many are. And because it's very easy to scale up when you kind of move to cloud-native technologies, we would encourage you, based on our experience, to look at your actual workload, such as the number of active sessions in your database instead of physical CPU cores. The actual physical reads from your storage tier instead of the IOPS and throughput capacity of your, like NetApp or storage machine in your organization. So base your sizing on workload. And again, we try to kind of show this information, some of it at least in Migvisor as well. And then you have to deploy your actual, Google Cloud targets, which includes, say, Cloud SQL for Postgres for the database, but also compute engines, VMs, for your applications, because you're going to test your applications. They need a virtual machine to run, so you also have to kind of do that as part of your environment setup. When it comes to schema conversion, again, I've kind of talked about it in the previous slide, but some tidbits here when it comes to moving your different database objects that you might have in your current schema right now from Oracle to Postgres, some of the challenges, and you'll have access to this slide, so to this deck, so you can kind of reference that later. But for example, object identifiers. So Oracle, basically, if you're using quoted identifiers, it converts it to uppercase. And Postgres convert them to lowercase, so this can break your SQLs, unless quoted, right? But we see quoted identifiers in a lot of the queries generated by certain applications. So that's one thing that can kind of cause pain when it comes to schema migrations. Database links, which we talked about. So Postgres has an extension, foreign data wrapper, that can give you equivalent database link functionality in the database, right? That's not supported in Cloud SQL right now. So you have to keep that in mind. Maybe for certain databases that are heavily relying on database links, you might be better off with Postgres on Compute Engine, or moving some of that logic to the application tier. Again, a partition table, so Postgres 9 has some does not have declarative partitioning support. It only provides table inheritance, which is not equivalent to what Oracle does as partitioning. Postgres then adds the support for table partitioning. Some of the Oracle partition types, not all of them. Postgres 11 expands that a bit further, but again, keep that in mind. Sequences, so you move your database, sequence values will have to be recreated. So you might have sequences right now that have like their value. So sequence A might be at a value of 10,000. Sequence B might be currently at a value of 256,091. So when you create the sequences in the target, you have to make sure that you actually, when it comes to the switchover, you resync your sequences, you advance them manually to their current state in the source Oracle database. Again, these are just some of the challenges you have to keep in mind. Even when you're doing a lot of this schema conversion using tools such as Ora2PG, there is stuff that you have to do manually. Triggers are also different, right? So a trigger in Oracle is both the event invoker as well as the logic. So you create a trigger on a table. The trigger will actually fire once when you insert a row, for example, once per row, and it also contains the logic. In Postgres, it's different. You have the trigger itself, which calls a function. So again, just kind of keep that in mind. Some other aspects, again, I don't want to go to all of that. That's a lot of the nitty-gritty, but there are aspects when it comes to schema conversion environment setup that you have to kind of take into account. By the way, this is all kind of surfaced in our product, but it's also, we thought it would be kind of nice to show some of those bigger challenges in the slide deck, such as using views instead of virtual columns, local temporary tables instead of global temporary tables. Temporary table behavior is different, so keep that in mind as well. Reverse key indexes are not supported. Bitmap indexes are not supported. Synonyms, you have to use views instead. So again, keep all of that in mind as you do the migration. There are data type differences. Again, this is it's boring, it's nitty-gritty stuff, but keep that in mind. Not all data types are supported as is. Even Oracle lobs, if you move them to the Bytea data type in Postgres, it has a 1 GB limitation, require API changes. So again, keep that in mind. And it's now you see why it's important to kind of surface all of those details before you actually start migrating, because you want to choose, maybe for the first database you move to Cloud SQL, you want to choose a database that's, I would say, easier to migrate and not necessarily your most complicated database in the organization. Some other stuff, such as certain changes in like how you invoke functions, certain changes in the SQL dialect, you'll have access to this deck. Just some tips, lesson learned from migrations we have previously done. But again, it's kind of like just kind of surfacing the challenges when it comes to schema migrations. A couple of things about stored procedures I want to mention briefly. So Postgres versions 9 and 10 only provide functions instead of packages and stored procedures. That's a challenge. You have to create functions instead of stored procedures. Postgres 11 finally adds a create procedure statement, right? So that's super cool. However, invoking functions and procedures are different, so you need to change that syntax in your application. And packages are not supported, so you need to use schemas in Postgres to group certain procedures or functions together. Certain Oracle PL/SQL control elements are also not supported. So again, a lot of stuff to take in. We don't have time for all of that, but just keep that in mind when you do your schema conversion. And again, reference this deck, and you can use our product for some other information that can save you a lot of pain in the future. So Postgres 10 and 11 also brings a lot of improvements when it comes to Oracle compatibility versus Postgres 9.6, such as enhancements of parallel queries. Again, this is a very nice slide. I kind of like cherry-picked some of the features which I think are most applicable when it comes to migrations, kind of cherry-pick those and put them in one slide. So you can have it as a reference, because Postgres 10, 11, they have a lot of functionality. Some of it is specifically relevant for Oracle to Postgres migration. So enhancements in parallel queries, such as parallel merge join, such as parallel index scan. These are things that the Oracle optimizer knows how to do, and now Postgres knows how to do them as well. We have full text search support for JSON and JSONB data types. We have additional performance enhancements, by the way, in Postgres 11, such as parallelized hash joins, super important. Covering indexes, finally, right? So that's another Postgres 11 features. You can use a create procedure, which is a new syntax not available previous to that, and you can call using the call syntax to invoke stored procedures in your database. But again, have this slide as a reference. Keep in mind that Postgres 10 and 11 bring a lot of new functionality that's more equivalent for what you might have right now in your Oracle environment. Okay, and when you finalize all the schema conversion aspects, automatic and manual, and you want to deploy your Cloud SQL instance, super easy, like a few clicks in the Google Cloud console UI. You can provision a Cloud SQL instance up to 64 cores and 416 gigabytes of memory, which, by the way, that's the limit for you. So if you have an Oracle database that has that you need more than 64 cores or 416 gigs of memory, you will probably need to split up this database and its workload to multiple smaller Cloud SQL instances in GCP. If you're migrating Oracle RAC, it's going to be a challenge, right? There is no way to do active clustering in GCP right now, in Postgres at all, by the way. It's not just like specific to GCP, but there are workarounds around that, such as moving some of that logic into the data access layer, into the application tier itself, so that you can actually maybe have like a fleet of Postgres Cloud SQL databases ready, and then you can do the hot swap via the application tier. You can also maybe kind of send application requests using a queue, such as Google PubSub, so that the data access layer kind of can, in case of failover, take those requests and route them to the Cloud SQL instance that will become available. So there are some workarounds about that as well. Oracle Data Guard is going to be a bit easier to migrate. You can use Postgres replication, which is natively supported in Cloud SQL. There are some challenges, such as cross-region DR, if you're doing that right now. But again, it's much easier. So RAC is going to be tricky, requires some application changes if you want to meet the same levels of high availability. Data Guard is a bit easier. But again, keep that in mind. It still needs to you need to know how to leverage the right Cloud SQL technologies to do that. You need to test for failover. So before you actually sign off on the new environment, you have to test failover. So once you provision everything, once you have your replication set up, once you have your high availability set up, you have to test failover before you move your production workload. You have to see that it behaves as you expect it to behave. You have to test your backups. You have to test your, how long it takes to recover your database. So and you have to, of course, configure monitoring and alerting. This is all part of the environment setup. And again, it's super, super, super important. Other steps. Now, I'm not going to go into like the next few steps. A, I don't have a lot of time, but B, there are other talks at Next which cover these aspects. There is a great talk from Aluma about data replication specifically. Just want to briefly mention that. So data migration. So after you've provisioned your Cloud SQL target, converted the schema, it's going to be a challenge, right? You still need to take care of moving your data, copying your data from your Oracle database to the cloud, to Postgres. There are a lot of tools that do heterogeneous data replication, right? So you can either use like a bunch of like ETL tools that are available. Informatica, for example, you might be using like Pentaho or Talend or Clover ETL. There are a lot of some open source or commercial tools that can help you move your data, right? But you also need to understand the concept of CDC data replication, which is change data capture. So if you use an ETL tool to move your data, that's a one-time copy. And that would require downtime when moving your data from your existing Oracle environment to Postgres, because you move the data, but data keeps changing. If people keep working on your source Oracle database, data keeps changing. So you will lose data on the switchover. And that's why tools that perform like real-time CDC change data capture, kind of like they read the Oracle review logs and they stream the transactions to the target in real time, are often used when you want to minimize downtime. Heck, many of you might be using products such as Oracle Golden Gate right now, which is a heterogeneous database replication product from Oracle. You can leverage that to move data to Postgres, for example. So there are a lot of tools out there. There is a great Illuma talk about data replication, at Next, which I encourage you to attend. But then again, keep in mind that the differences between one-time loads and real-time replication. So again, I talked about it in the previous slides, so I'm not going to iterate, but you'll need to make sure that you take into account both loading what you currently have in your database, as well as kind of how you're going to plan and stream changes to the target. You'll need to test your applications. We talked about it. A couple of points I want to mention. So you have to stress test your existing database, your new Cloud SQL database, and see that it meets your performance characteristics. You need to make sure that your application workloads, SLAs in terms of like query performance and query responsiveness are met. Okay, we talked about it essentially, but that's stuff you have to do only after you migrated the data. So only after you have like a working copy of Cloud SQL Postgres, for example, with your data and the compute engine servers for running your applications, that's where you can kind of like test your applications. So that's, again, something you have to do. And also keep in mind that it might be worthwhile to create a reverse replication flow. So in case you have to do a rollback, so let's say you planned everything, you executed everything, everything is great, but then after you went live, you found out an issue, maybe an application you did end up forgetting. So you'll need to kind of think about creating a reverse replication flow just in case you want to roll back your changes and move back to the original Oracle database until you work things out, because otherwise, if you just set up a one-way replication process and you move to your new Postgres target and you start working with it, changes applied to Postgres would not be replicated back to Oracle, and they will essentially be lost. When you switch, if you need to switch back. Let's hope it won't happen, but sometime it might happen. So again, we talked about all of that. It's in the deck. I don't have a lot of time, so I'm gonna go briefly over that. But again, we talked about that, and it's in the deck for reference. So do application QA, make sure your applications behave as expected, right? Nothing breaks and performance is good. Do query QA and database QA, right? Both on the workload side, but also making sure that you can fail over, that you can backup and restore, the time it takes to backup and restore. So you'll know your IT is, set up as you need it. So you test high availability, you test DR, you allocate time for performance tuning. This is all part of the migration validation step. Compatibility of application, we talked about it. Some modern applications might be more compatible with Postgres. Legacy application might not be as compatible. So it's very important to map the applications that connect to your database right now. Are they legacy? Are they modern? Are they using the Oracle call interface, custom drivers, JDBC, ODBC? Java applications would probably be easier to port versus, I don't know, C++ or, I don't know, like COBOL applications, some of the legacy stuff. So you need to make sure that your applications are compatible. It's also sometimes there is a difference between porting in-house applications to third-party applications. So if it's an application you developed in-house, you might have the resources internally to make the changes needed to support, I don't know, Postgres or MySQL if needed. If it's a third-party application, maybe, and it's not supported, then that's going to be a problem, right? So map your applications for compatibility and identify specifically legacy applications that, would probably make your migration a whole lot more complicated. We talked about performance. Bottom line, switching database engines, queries will behave differently, no matter how compatible you are and how much you think that you're only using ANSI SQL, so plan for performance testing as well. We talked about rollback strategy just a bit, right? So create a reverse replication flow for your data migration, making sure changes are applied back to the source database. I'm sorry. And keep the old environment around after you go live with the new environment. Keep the old environment around for at least a few days, maybe a few weeks, just in case. Maybe you forgot there is a script running on the cron tab of the Oracle database that you forgot about, right? So just keep it around because you might need it. Again, this is like rudimentary stuff, but we saw a project where people went live, closed the old environment, and then figure out that they missed something.